Hi guys, this is Mrs. Delise. Welcome to another lesson of Algebra 2. Today we're going to be learning polynomials of 4, solving polynomial equations, determining the remaining zeros. We have our two learning objectives. I will learn how to determine the number of zeros for a given polynomial. The number of zeros is also the degree of the polynomial. I will learn how to solve a polynomial equation given one or more factors. So, let's start with example number 1. I recommend that before watching this video, you watch the video about how to do completing the square, how to do quadratic formula, and how to do synthetic division. Those three things are needed in order for you to be successful in learning this lesson. We have x cubed plus 8x squared plus 9x minus 58 equals 0, given that x equals 2 is a solution. And I would like to remind you that x equal 2 is coming from factored form x minus 2. Okay? And so because we are dividing x cubed into an x, then we are going to have x squared as our result later on. Now, there are two choices in dividing this polynomial into x minus 2. You can use long division, polynomial long division. You can use synthetic division. But in all of the examples that I will be doing here, I will be using synthetic division. But if you feel like you want to use long division, it's okay. And you will get the same answer. I'm going to move on into doing synthetic division. I will put my factor here, which is one of the solution, which is 2. I put that in the corner. And then I will write all the coefficients of my polynomial, starting with x cubed with a coefficient of 1, 8x squared with a coefficient of 8, and then 9, and then we have negative 58. And I need you to remember that when you are using synthetic division, you need to make sure that your factor here is after you made it equal to 0. So if you have an x minus 2, you make that equal to 0, you'll get that x is equal to 2. Right? And because the given solution is already x is equal to 2, I do not have to make that equal to 0 anymore. Just in case if you're confused between the video between synthetic division and this video. Okay, let us move on into bringing the first coefficient, which is 1. That's the first step in synthetic division. And then you will multiply the number that you brought down, which is 1, and you multiply it with your solution, which is 2. So 1 times 2 is 2. You'll put that under the next coefficient. You'll add the two numbers. 8 plus 2 is 10. And then you will multiply again. This 10 times 2, we have 20. And then you'll add 9 plus 20. Of course, you'll get 29. And then moving on with multiplying 29 and 2, that will give you a positive 58. And then adding negative 58 plus 58 will give you a 0. That means that you are done. You are done dividing x cubed plus 8x squared plus 9x minus 58 equals 0. And you divided that with an x minus 2 or an x is equal to 2. And because remember earlier, we are dividing an x cubed to an x, we will get answer. Our answer should start with an exponent of 2, which is x squared. So this answer be translated into 1x squared plus 10x, or x squared would do. You don't have to write the 1, plus 29 equal to 0. Now, if your goal is to just divide the polynomial, then we're done dividing. But our goal in here is to find the remaining zeros, to find all the x's, the values of x. And we already have x is equal to 2. And because the degree of the polynomial is 3, what do I mean with the degree of the polynomial is 3? That is the highest exponent of the polynomial. I am expecting to have 3 different solutions. So I have an x is equal to 2, and I need 2 more. And because I don't have it, I need to get those remaining zeros from this quadratic equation, x squared plus 10x plus 29. Now you have 3 ways on how to get those. First is you factor. If it's not factorable, then you do a completing the square or quadratic formula. And because these quadratic equation is not factorable, I will be using completing the square. Now, you now have choices. You either do a completing the square or a quadratic formula. Because I have a nice b value, which is 10, I will be using completing the square this time. So we have x squared plus 10x plus 29 equal to 0. Again, let's name it. I am doing completing the square. And to those who are new into watching this video, if you're a new student or something, please note that I already made a video on how to complete the square, so you can watch the previous video on it. So I have x squared plus 10x equals negative 29. And then I'll get the b value, divide that by 2 and square it. That would be 10 divided by 2 is 5. 5 squared is 25. Therefore, I'm adding 25 on both sides. Negative 29 plus 25. And then I'll factor x squared plus 10x plus 25. That is an x plus 5 and x plus 5. And that would be negative 4. Combining that into x plus 5 squared, I have a negative 4. And then solving the value of x, I have plus and minus. So I'm going to square root both sides to cancel the squared. And so I have an x plus 5 left equals plus and minus a square root of negative 4. Moving on, I have an x plus 5 equals the square root of 4. That is a 2i. And lastly, I will need to remove the positive 5. So I'll have to subtract 5 on both sides. My final answer is now x equals negative 5 plus and minus 2i. So I have my 2x values. I have a negative 5 plus 2i, and I have a negative 5 minus 2i. So this is your final answer. Okay? Now, Miss, you did a lot of things, and I'm not sure if I'm following you in here. First, we did we did synthetic division. This is coming from a previous lesson. Then we did a completing the square, which is again coming from a previous lesson. What I'm doing here is combining synthetic division and completing the square to look for the remaining zeros. Okay? Now, I'm going to go through 2 more examples, and hopefully you will get better at this. We have solve x cubed plus 8x squared plus 14x plus 4 equals 0, given that x is equal to a negative 2. Again, I am dividing an x cubed to a factor of x plus 2, so that's x plus 2. And so my expectation would be that I will get an x squared at the bottom. Now, state the number of roots of this polynomial. Number of roots is the degree of the polynomial. Since the degree of the polynomial is 3, I am looking for 3 different values of x. I already have one, which is a negative 2. So technically, I'm looking for 2 more values. Okay, I'm hoping that that makes sense. First step is I'm going to do synthetic division. I will put the negative 2 on the corner, followed by the coefficient of my polynomial. From the x cube, I'll get 1, followed by 8, 14, and 4 all over. And if you have the packet, this example is going to be on page 5. Okay, I'll move on bringing down my first number, 1. I will multiply 1 and the negative 2. That's a negative 2. I will combine 8 and a negative 2 by adding. That is a 6. I will multiply 6 and negative 2, and that is a negative 12. I'll combine 14 and a negative 12 by adding. I'll get a 2. And then lastly, I will multiply 2 and negative 2. That will give me a negative 4. So, because we're dividing x cubed into an x, this would represent x squared, or 1x squared, plus 6x plus 2 equals to 0. Again, you do not have to put 1 in the 1x squared. You can obviously leave it as just x squared. Now you have a choice of factoring, quadratic formula, or completing the square to look for 2 more zeros. But it does not look like it's factorable, right? There's no such thing as, like if you factor that, there's no such thing as factors of 2 that will add to 6. And because we can't factor it, we will be using completing the square, because I have a nice b value 6, or I could use a quadratic formula. Okay, I will be using completing the square in here. I feel like that's the fastest. So I'll have, let me rewrite that one in here in a different color. So you have x squared plus 6x plus 2 equal to 0. First step is to get rid of the c value. We have plus 6x equals negative 2. And then we'll look for the number that will complete the square by getting the b value and dividing that by 2. So 6 divided by 2 squared, 3 squared, that is a 9. So we are adding 9 on both sides of the equation. I hope you do remember. Then you factor this. This is two numbers that, a factor of 9 that will add up to 6. So that is a 3 and a 3 equals positive 7. Okay? Combining that into 1, we have an x plus 3 squared equals positive 7. And because we are trying to find the value of x, we will get rid of everything. Let's get rid of the squared first. That will turn that into an x plus 3 equals plus and minus square root of 7. What's the square root of 7? Square root of 7 is just square root of 7, right? You cannot simplify that anymore. Of course, you can put that in the calculator and it will give you the decimal value of the square root of 7, but that's not the goal in here. We'll just simplify it as a radical. So because we can't, we just leave it as is. And then all we have to do now is get rid of the 3. Our final answer is x equals negative 3 plus and minus square root of 7. So I can write it separately. Negative 3 plus square root of 7, negative 3, minus square root of 7. Or you can just really write negative 3 plus and minus square root of 7. Okay? I hope that is not that hard. Again, you could, instead of completing the square into this red section here, you can use quadratic formula. It should give you the same answer. Okay, last one. Or we could do 2 more if that is needed. We have to solve for 3x to the power of 4. Then we have 11x cubed Negative 36x squared minus 77x plus 15 equals 0. Given that, if you know this now, we have two solutions given in here. State the number of roots of this polynomial. Of course, because our polynomial has a degree of 4, we are looking for 4 different answers. Right now, you are given 2 of them. So technically, we're looking for 2 more. Let's start with our synthetic division. Now, which one do I have to use? Should I use negative 5 or should I use positive 3? The answer to the question is you will be using both. So it doesn't matter which one you use first because you will be doing both anyway. So I'll start with the one that is given first, which is a negative 5. So I'll put negative 5 on the corner, followed by all the coefficient. We have a 3, 11, negative 36, negative 77, and we have a 15. So, oh wait, sorry, that's 2. Let's start. Moving down to 3, bringing down the 3, multiplying the 3 and the negative 5, that's the negative 15. 11 minus 15 would be negative 4. Negative 4 times negative 5 will be positive 20. Negative 36 plus 20, negative 16. Negative 16 times negative 5, what is that? That is positive 80. Negative 77 plus 80, you'll have a 3. 3 times negative 5 is a negative 15. So you'll know when you're done if and when you arrive 0 at towards the end. Okay, now here's the problem. When we use a completing the square or we use a quadratic formula, we need to make sure that we only have A, B, and C, right? We have a quadratic. Right now, it is not quadratic yet because this one would be a 3x cube, right? Then that's the reason we will do 2 synthetic division. And I will be using these numbers. I hope you focus. I will be using this number in order for me to do another synthetic division. So I'll do another synthetic division using the numbers I have here. But instead of using negative 5, I'm going to be using the x is equal to 3. So bring down the 3. 3 times 3 is a 9. That would give us a positive 5. 5 times 3 is a negative 15. Oh, sorry, positive 15. Negative 16 plus 15 is a negative 1. 3 times negative 1 is a negative 3. So we are now down to 3x squared plus a 5x minus 1 equal to 0. Now you have the option of doing completing the square or doing quadratic formula. Now, earlier, for both of the questions in the first and the second example that I did, I was using completing the square because they have nice b values. But in this case, I don't have the nice b value anymore. I have a 5. Right? And I have an a value that is a 3. So, of course, you can still use the completing the square, but it would be confusing. So, I suggest in this type of example, you use quadratic formula. So, hopefully, you still remember your quadratic formula. We have b squared minus 4ac over 2a. So let's have, that's my A, that's my B, and that's my C. So that's negative 5 over 2 times 3 plus and minus negative 5 squared minus 4. A is 3, C is a negative 1, all over 2 times 3. So this is x equals negative 5 over 6, right? Because 2 times 3 is 6. Square root of 25, because negative 5 squared is 25. We have negative 4 times 3 times negative 1. That's a positive 12. All over 6. X is equal to negative 5 plus 6. That is a square root of, that's a square root of 37 over 6. What's the square root of 37? You can't simplify 37 anymore, right? So that means this is it. This is our final answer. So our final answer is, of course, you can have it written separately. Negative 5 over 6 plus and minus square root of 37 over 6. And there you have it. You now have 4 different answers. You have a negative 5, which is given, positive 3, which is given, and then you have negative 5 over 6 plus and minus square root of 37 over 6. Remember, this is counted as 2 different answers, 2 different zeros. Okay? Thank you guys for watching. I hope that you understand what I'm doing over here. If you have any questions, any confusion, please, if you need more examples, please let me know. Thank you for watching. I'll see you on the next video.